Okay, let's try this question where they're asking about the sweetness of a peach T days after it begins. So it's a certain amount of time. It's going to be a rate problem. The sweetness, the units of sweetness is kind of a strange thing. I understand kilometers per hour and meters per second and, liters per minute, but sweetness, I'm not sure. Anyways, this is the formula. Oh, by the way, there's a mistake. I ended up playing with lots of different things with this because in the questions it's got a minus here, but it should be a plus. It's got to be a plus to make any sense. So first it says at what's the rate of the sweetness increasing when t the time is at 0 right in the beginning. Oh, at what rate is the sweetness increasing in the beginning of time here, t0? Well, what you're going to have to do is you're going to have to multiply t minus 15 cubed out before we even get started. And if you know what the difference of a minus b cubed is from grade 10, you'll be able to write this out. You might have to multiply it out if you don't. But it is a cubed minus 3ab squared, a squared b. Anyways, if you know the formula, you can just write out the answer. But you might have to multiply it out. You'll get this, t cubed minus 45t squared, 675t, and minus 3375. And then you'll go 330 minus this, you'll get minus 75. And then just add all these other things. There's the formula of ST. We're going to have to find the derivative of that. So that makes it 3t squared minus 9t plus 675. So what does that mean? The rate of change when we put 0 in here is 675 sweetness units. What is a sweetness unit per day? That's it. Okay, the next question says, a peach falls off the tree when the sweetness stops increasing. For how long does the peach stay on the tree? So just as long as it's increasing, we need a turning point. And I think that's what Mr. Autry did. He had s prime of t equals 0. We got to take the derivative and make it equal 0. But let's divide all these numbers by 3 and make it easier. T squared minus 30t plus 225. That gives you t minus 15 squared. Hey, what makes it 0? Just one thing, just 15. Gee, that's kind of interesting that there's only one answer here. In fact, and that it's always going to be increasing. It can be 0, but at at the turning point, it's increasing, and on the other side of the turning point, it's increasing. So that's a bit of a different cubic equation we don't usually work with. Let's try the last question. Sketch the graph. Now, Mr. Autry did this thing. He went, okay, what's the y-intercept? That's what you do when you're sketching graphs. We're going to sketch this graph. Well, it must be minus 75. That's how we got that. And then at 15, when I put in 15, I know I get an answer of 330. And what makes this special here at 330? Well, I know it's increasing. It's increasing and increasing and increasing all the way. But then it's 0 right there. But then on the other side, at 16 and 17, the gradient is increasing as well. So it's concave down, then it becomes concave up. Hey, that's kind of like a point of inflection too, right there at 15. Now, when I looked at this, I was wondering, we don't know exactly, we don't have to know. This is the shape of the thing. It comes up like this and goes like this. I got curious and I put this equation into GeoGebra. And boy, that's a long ways up there at 15 and 330. So, hey, this shape that Mr. Autry's got is exactly right. And this way down here hits around minus 75. The x-intercept, if I wanted to make this 0, this would have to be negative 330. And the cubed root is 14.88. Gee, I guess it must be really close there at 0.112. That's the x value where it goes. We don't need to know that. We need to know the basic shape, that it's increasing, then it goes to 0, and then it's increasing again. You have 15 and 330 in there, and the minus 75. I'd say that'd be enough information because you don't have a computer to to figure out the sketch of the graph, and the numbers are gigantic, so it would be pretty hard to sketch. But you can get the idea just the way Mr. Autry did.